All right. So the whole idea behind Hess's law is it doesn't matter how you get there, as long as you get there. Here's a lovely picture. If you've got to get to school from home, but you got to stop at McDonald's on the way to school, have a snack. Yes, I'm having a little chocolate. Doesn't matter. Your mom probably doesn't care as long as you get to school. I know I would like it if you went to McDonald's, if you brought me a Diet Coke. But I wouldn't. I don't care as long as you're at school. Okay? Now, that's really hard to explain algebraically, and I'm going to work on finding something good for an example of that. But in the meantime, basically what we're going to do is we're going to put reactions together. Okay, so this is our reaction. We've got lead 2 chloride, we're making lead 4 chloride. But we cannot find a delta H for this. However, we know that lead 2 chloride can be made from lead plus chlorine, and lead 4 chloride can be made from lead plus chlorine. And we have delta H's for those. So if we can figure out and mush those together, we can come up with the delta H for our parent reaction. Okay? The best way to go about tackling these, in my opinion, this is how I do it, find lead 2 chloride right here. He's on the left-hand side, the reactant side, so he's good. I can see I have chlorines in both. I'm going to skip those for the moment. Lead 4 chloride needs to be on the product side. Is he? No. So we're going to get rid of him, or not get rid of him, we're just going to move that down for right now. We're going to flip him around. And I wish I had something magical and I could do that really cool, but instead I'm going to do that. And now we have flipped it around. So here's our lead chloride. So we have lead chloride plus chlorine produces lead 4 chloride. Okay? Notice the charge changed when I flipped that. Also notice, in algebra, if you're putting equations together and you want to simplify it, you can cancel out like terms. So if we add these all together, we get lead chloride, lead 2 chloride, plus a lead, plus 2 chlorines, produces a lead, a chlorine, and lead 4 chloride. Okay? If I am in math, I want to get rid of like terms, so I'm going to subtract lead from both sides. Oops, what happened? It's gone. Right? I also want to get all my chlorines on one side, so I'm going to subtract chlorine from this side. If I do that, this side is wiped out, and I have 1 chlorine left. Well, remember we have that chlorine in there. Guess what? There he is. Now all we have to do is put the H's together. We add them all up. So we take 359.4 plus a negative 329.3. I don't know about you. That's a subtraction problem to me. And you get 30.1. And it's positive 30.1 kilojoules. Let's try this guy. I'm going to hide my flip one so it'll be more dramatic. We want sulfur, and we want start with sulfur, and we want to make sulfur dioxide. So the first thing I'm going to do is look for sulfur by himself. And here he is in my second equation by himself, but he's on the product side. What do I have to do when that arises? Well, I'm going to flip it around, and I'm going to do that. And now, whoops, I want to get rid of that guy. My sulfur's on the correct side. Uh-oh. I have 2 sulfurs. How many do I actually need? I really only need 1. Okay? So I am going to divide this whole thing by 2. 2 divided by 2 is 1. 3 divided by 2 is 3 halves. 2 divided by 2 is 1. 790 divided by 2 395. And it's negative, right? Negative. Come on. And there we go. Okay. We want sulfur dioxide. Do we have sulfur dioxide in either of these? Actually, yes, we do, right here. He is on the product side, so he's in the right spot. But again, we have 2, we only need 1. So we're going to go ahead and divide this whole equation by 2. That gives me 1 sulfur trioxide, 1 sulfur dioxide, and a half of an oxygen. Now I'm going to put them together. Okay, 2 over 2 is 1 SO3. 2 over 2 is 1 S plus 3 halves oxygen. 2 over 2 is 1 SO2 plus 1 half oxygen plus 2 over 2 is 1 SO3. If I'm in math, I'm going to combine like terms, so those cancel themselves out. Now I have 1 sulfur plus 3 halves oxygen gives me 1 sulfur dioxide and a half of oxygen. Again, let's combine our like terms. If I subtract 1 half from both sides, 3 minus 1 is 2. We end up with 2 halves of 2 halves, which is 1. 1 sulfur, 1 oxygen, 1 sulfur dioxide. I'm going to find one more example. And I have to go back to 2015. And I got to do this quick because I got to go, we're going out to dinner for Joe's birthday. That was a burp. I just didn't want to burp in front of you. Okay. The desired chemical equation that we want is right here. 2S plus 3O2 gives us 2SO3. Okay. Apparently I have him on here twice. Okay. So, again, start with your parent. I have 2S. Do I have any sulfurs down here? Yes, I do. How many do I have, though? I only have 1. Last time I had 2. This time I only have 1. So I'm going to multiply everything in this equation by 2. And I'm going to multiply this guy by 2. At least he was on the reactant side. Not going to worry about oxygen, because there's oxygens in both of them. I need 2 sulfur trioxides. Do you see any sulfur trioxides down here? You do? Well, looky there. But what side is he on? He is on the reactant side. And where do we want him? We want him on the product side. So we're going to flip our equation. What do I have to do, though, if I'm going to flip that equation? This needs to become negative. Okay? So I can bring this guy back. I can bring my highlight back up. Now, I'm going to mush them together. 2S plus 2 oxygen plus 2 sulfur dioxide plus 1 oxygen will give us 2 sulfur dioxide plus 2 sulfur trioxides. 2 plus 1 would give me what? 3. So that guy's gone. Sulfur dioxide, if I combine like terms. So I just got rid of this, and this, and this, and looky there, folks. Isn't that our equation? So, we've done that. Now we've got to add this guy up. 2 times negative 297 that didn't work. 2 times 297 2 times 297 equals, so we have a negative 514. We don't have to do anything to this guy except for he's already he's negative. We changed him to negative. So now we're going to add 514 plus 198. So I'm going to do negative 514 minus 198, negative 712 kilojoules per mole. Okay, hopefully that helps. We have some things we're going to do tomorrow and Friday.